In this video, I would like to demonstrate one of the variance reduction techniques, which is the so-called antithetic variance technique, as you can see the name here. So this is probably the simplest variance reduction technique among the ones that we have seen. So the basic simple example here is for simulation of the European call option pricing problem. And in our simulation, you can see we have, first of all, the parameters of our option: initial stock price, strike, risk-free volatility, and time to maturity in terms of years. And then you have N, which is the number of paths that we will use in our simulation. Since this is just call option pricing, I can just directly simulate the last step. So I don't need to simulate the steps in between. And this is our delta. We have our initial S1, and then basically we need to sample our standard normals. And since M is just 1, this is a vector of standard normal random numbers. So we can also calculate the exact price using the Black-Scholes, and we can find out what's the relative error from Monte Carlo simulation. So you can see here, this is our regular for loops. I mean, if you want to write a code to simulate the stock prices, since M is just 1, this is actually just single step, but you can do it also with multiple time steps for different payoff functions. And you need to always start from S0, and we are simulating n number of paths. And essentially the Monte Carlo estimate will be the average payoff, I mean the average discounted payoff, of course. So this is what you get as the Monte Carlo price. And you can calculate the relative error, as you can see here. So what's the antithetic variance technique? Basically, since we are dealing with a symmetric distribution, Z, I mean the standard normal, to make it perfectly symmetric, to make my sample perfectly symmetric, I can use my original Z and combine it with minus values of the original standard normals. So when we combine these two sets of standard normals, basically we will get a perfectly symmetric Z. So ideally, it will make our estimation more accurate than the original one that we have here. So also pay attention that we have this basically 2 times n this time, because since we combine these two z's, our sample of simulation is doubled. So the same 2 times n occurs here. So essentially everything else is still the same. There's just this small key step that means we are using the antithetic variance technique, since we, as I said, since we are making a perfectly symmetric sample of standard normals. So that should ideally, or in most cases, will improve your estimation of the price. So if you try, for example, in this run, if I run my code, I can see the exact price for the call option, for the put option, and here we are just doing for the call. So the relative error, if we use the antithetic variance, is 0.0055. So it is some improvement from the compared to the Monte Carlo relative error, as we can see in this experiment.